Welcome. This podcast is going to be the virtual lab for our mass loss lab in chemistry. From this podcast, if you were absent, you will be able to get a data set. So to get started, the objectives for this lab are to identify the limiting reactant and the theoretical mass in grams of carbon dioxide that will be the lost in the reaction between baking soda, sodium hydrogen carbonate, and hydrochloric acid. Then, using your experimental yield of grams of carbon dioxide lost, calculate your percent yield and percent error to prove whether or not your claim is valid. If your claim is not valid, describe the possible sources of error and their resulting effect on the experimental yield and percent error. So the principle behind this lab is the law of conservation of matter. If you remember, the law of conservation of matter states that the mass of the reactants should be equal to the mass of the products in a closed system. We're going to do this lab in an open system, so the mass of the reactants will not be equal to the mass of the products because some of our products will escape the open system, and the difference in mass between the reactants and products can be used to deduce the mass of the products that left and escaped that open system. So your EQ is what mass in grams of carbon dioxide will be lost in the reaction of baking soda with hydrochloric acid. And you can see we have our balanced reaction written out below. It's one we've used in several labs before. The carbon dioxide gas will be what leaves the open system. The beaker that remains will have sodium chloride, aqueous in solution because liquid water will be present, and salt dissolves in liquid water. So on the other side of the reaction, the beaker will contain our salt and our liquid water, but the carbon dioxide gas, because we're performing this in an open beaker, will escape and leave the system. The difference in mass between the reactants and the products that remain will give us indirectly the mass of the carbon dioxide gas that was produced. Our method is pretty straightforward, but there's a lot of different data points you need to collect today. So we need to record the mass of an empty small beaker and then measure and add exactly 1 gram of baking soda. Record the mass of the beaker with the baking soda. Then we're going to use exactly 10 milliliters of a 0.5 molarity hydrochloric acid, which you should measure out precisely. That means pour from the beaker until it's close to 10 milliliters and then squat down with your eyes at the level of the meniscus and use a pipette to add the remaining acid. Finally, record the mass of the graduated cylinder with the hydrochloric acid together. We're then going to be able to isolate the mass of just the hydrochloric acid once we add it to the beaker, so we know the initial mass of all the reactants in the reaction. Once you have all the initial masses, slowly pour the acid into the beaker, making sure to not spill over, controlling the rate that the reaction happens. And then measure the mass of the empty graduated cylinder after you've poured the acid out and record it. Carefully decant, pour off carbon dioxide gas. What that means is that we don't want to lose any of our solution, but carbon dioxide is heavier than air and it kind of fills that beaker. So we need to kind of tip the beaker so no solution comes out, but the heavier gas would spill away. And then measure the final mass of the beaker containing the sodium chloride and your water products. Record the mass of the beaker and products in your data table. And then you can pour solutions down the drain, rinse your glassware, and place your sink. Place everything upside down on a paper towel to dry for the next period. One big hint is to make sure that the scale always reads 0 before you mass anything. Small errors in mass measurements become writing an error analysis and a percent error statement. So we do have a lot of data we're collecting today. On your data table, the data in the white columns is data you need to measure and record with the asterisks on it, whereas these are calculated values that are in the gray background. So when you see the squares, that's values you calculate after you collect data throughout the experiment. All right, let's take a second and have you collect a virtual data set. Please record the mass of the empty beaker. Now we're going to add exactly 1 gram of sodium hydrogen carbonate, baking soda, and you'll need to record the mass of the beaker with the baking soda added. Now that we have the mass of the beaker with the baking soda, we're going to measure out exactly 10 milliliters of hydrochloric acid using a graduated cylinder. I've already pre-poured some of that acid into the grad cylinder, so I'm now just going to add drop by drop until I get to that 10 milliliter mark on the meniscus. And I need to get the mass of the graduated cylinder with the hydrochloric acid. Be sure to record that. And now we'll slowly and carefully react to the hydrochloric acid with the baking soda, making sure that we control the rate at which that reaction happens so we don't lose any of our product. And then we're going to measure the mass of the empty graduated cylinder. From the last 2 measurements, we can now figure out the exact mass of hydrochloric acid that went into the beaker. Finally, we need to let the reaction finish. So since a gas is being produced, we'll know the reaction is done when we see no more production of gas, no more dissolving and formation of carbon dioxide. Your job is to figure out the limiting reactant. Sometimes there's visual clues that can tell you what's fully consumed and what's remaining at the end. So you might want to look at that beaker carefully and think about, is there a way I would know what the limiting reactant was? And finally, record the mass of your beaker and products. All right, so now you need to process the data. Make sure you calculate and find the mass of the baking soda reacted, the mass of just the hydrochloric acid reacted, and the mass of your 2 products that remained in the beaker. Remember, carbon dioxide gas escaped the beaker because it's an open system. You're going to then use these 3 calculated values in gray to think about what you know and how you can figure out and infer the mass of just the carbon dioxide. So if you put your 3 calculated values into these 3 spots, and you remember that the law of conservation of matter says that the reactants on this side should be equal to the mass of the products on this side, can we go back and figure out how much carbon dioxide gas left the system? All right, now you're going to need to use stoichiometry to determine your theoretical yield as well as limiting reactant. So please make sure that you start with the volume of hydrochloric acid that you reacted, 10 milliliters of hydrochloric acid, and use the molarity of the hydrochloric acid as a pathway to solving for how many grams of carbon dioxide gas would leave the system. Do the same thing with your initial amount of baking soda you reacted. And from your 2 stoichiometry calculations, make sure you identify your theoretical yield of carbon dioxide as well as your limiting reactant. Once you have those 2 things, you should be able to calculate your percent yield and percent error, and then write your claim. Please make sure that your claim answers all of the essential questions. Thanks for listening. Have a great day.